Boof, here it is, guys. I have to say that we've been waiting for these data because the scientists were hoping to explain the mysteries of Interstellar Object 3I Atlas with these data. But can they? Or is it vice versa? Well, guys, I can already tell you it doesn't explain. It adds more to the mystery. Our gigantic interstellar visitor 3I Atlas and its weird behavior. Let's name this video about that because many of you might have wondered what it would be like if something from another solar system showed up, or another star system showed up in our solar system, looked totally different than anything we've seen before, and then kept surprising scientists again and again. Not so much NASA, it seems. They're like, it's a comet, nothing to see here, no more comments. CIA says, we're not telling you anything, it's classified, which makes you wonder a little bit, right? Well, I said it keeps surprising scientists again and again. And well, that's exactly what just happened with 3I Atlas. And I want to break down the latest findings there for you from the Hubble and the James Webb telescopes. All the numbers, all the weird behavior explained so that we can understand what's going on. And it's mind-breaking again. And one thing that comes to mind is the massive nucleus of 3I Atlas. So let's kind of start at the beginning with the new data that have been released just right now from two powerhouse, we have to say, space telescopes, Hubble and Webb. So we're dealing with actually two scientific reports that have been posted online that give us our most detailed look yet at this interstellar visitor. So Hubble has detected the nucleus, and I want to show you the images, and this needs some explanation. So the first image here shows like 3 panels for each visit when they looked at it, right? On the left is the actual raw Hubble image of 3I Atlas, and then in the middle scientists applied a model like of the dust cloud that is called the coma that surrounds 3I Atlas and kind of hides what is 3I Atlas. What's the core? Is there something on it, right? On the right, they have subtracted that dust model from the real image and successfully isolated the solid core, which is called the nucleus of 3I Atlas. And when you see these arrows and the markers in these images, they show the directions like northeast, and also that's important, the direction away from the sun. So you see a white horizontal bar at the bottom. It shows a length that is equal to 1 arc second, which at the distances that are involved here represents about 1,300 to 1,700 kilometers of actual space. So 1 to 1.2 miles, 1.3 miles. And there's a big discovery that they just now made about the size of the nucleus of 3I Atlas. So from the new data, the scientists estimated that the effective diameter of 3I Atlas's nucleus, just the nucleus, is about 2.6 kilometers, 2.2 miles, with an uncertainty of plus minus 0.4 kilometers, 0.2 miles. That number assumes a typical comet albedo, which is just a fancy way of saying how much light does the surface reflect. It's set here at 0.0.4. It's very dark. Let's put that into perspective so that it gets clearer what I'm talking about. This thing is about 40 times more massive than the interstellar object 2I Borisov, whose nucleus was only about 0.7 kilometers wide, 0.4 miles. And it's at least, and that is stunning, 20,000 times more massive than the first known interstellar object, 1I Oumuamua, which was less than 0.2 kilometers long, 0.1 miles, and much thinner in at least one dimension. So 3I Atlas is huge. And what we know now about it after its closest approach to Sun, what's happening after the perihelion, when 3I Atlas was passing the closest point to the Sun on October 29th, 2025. Before that, it was getting brighter, fast, brightening as it approached. But after perihelion, something changed. It faded faster than expected. Absolutely weird. And its dust brightness profile became shallower than before, meaning the way the coma spreads around it, it has changed significantly. Why? Scientists also noticed variation in brightness that suggests the object is rotating. We talked about this, the wobbling of the tail, right? And on January 22nd, 2026, when we had that lineup of the Sun, Earth, and 3I Atlas, the dust around it got 20% brighter in a way that matches predictions from light scattering theories. So let's have a look at the larger picture to find out what that really means. From the new Hubble data, researchers estimate that at any moment there's more than one object as large as 3I Atlas within a sphere about 4.5 astronomical units from the Sun. That's their assumption. 1 astronomical unit, short AU, is the distance between the Earth and Sun. So 4.5 times the distance between Earth and Sun. So since this is a lower limit, it likely means many interstellar visitors like this have already passed through our solar system undetected, especially before modern telescopes existed. That's the assumption, right? But now let's go to the James Webb telescope observations. Webb took what's called a spectrum, and that's what we've been waiting for. A spectrum of 3I Atlas on December 15th and 16th, and December 27th, when the object was at distances of about 2.2 to 2.54 AU from the Sun. So we're looking right now in this image at the spectral data, basically how much light is coming from different molecules around 3I Atlas. The main features that we have highlighted there is the water, carbon dioxide, nickel, methane. And there's also a zoom in panel just on the CO2 features. When we compare the two Webb observation times, the total gas output from the object dropped. It dropped significantly over 12 days. The water levels dropped more steeply compared to other volatile gases, though the icy grains around the object continued producing water. So, let me give a short breakdown from the Post-perihelion Webb telescope. CH4, methane, made about 13.7 and 27% of the water production rate in the two observation periods. In one period, 13.7%, in the other one, 27%. That's a huge difference. And this is particularly interesting because methane is hyper volatile, meaning it usually sublimates and escapes at much lower temperatures than CO2. So if methane were just sitting near the surface, it would have been releasing before perihelion, before. But it wasn't detected either by Webb or earlier data that we have from Sphere X in August 2025. What? Really let that sink in. That means methane isn't prevalent in the outermost layer of the object's surface. That's the only conclusion. Instead, it seems to be deeper down. And it only became exposed as the sunlight has warmed the interior after Atlas was passing closest to the sun. So this creates another puzzle, another mystery, because carbon monoxide, CO, which vaporizes even more easily than methane, was detected early on, even though it should have been depleted if methane was not on the surface. So how in the world is this possible? There's no explanation. But that's not the only thing. We have a weird, we have to say, weird spectrum after perihelion. Let's have a look at this image. So this image shows us the brightness distribution differences, like places where certain molecules are stronger, that's in red, or weaker, that's blue, then like a perfect circular shape around the object. And these patterns are telling us where the jets or tails of gas and dust are forming. We see the arrows again. They mark the directions opposite the motion of 3I Atlas and opposite the sun. So on November 16th last year, after perihelion, on November 16th, the Keck 2 telescope in Hawaii also observed 3I Atlas at about 1.5 AU from the sun and 2.089 AU from Earth. And interesting, there is the nickel to iron ratio. Before perihelion, scientists saw that 3I Atlas had way more nickel compared to iron, way more than typical comets. In fact, it was higher than any solar system comet observed at similar distances. And then as 3I Atlas moved away from the sun, this nickel to iron ratio shifted closer to what we see in common solar system comets. So was it adjusting? Let's have a look at another chart. It shows how the production rates of various molecules happened. Like cyanide, yeah, it had cyanide, tricarbon and dicarbon, C2. They change with distance from the sun after perihelion. Cyanide decreases faster with the distance than the others. And then, when researchers removed the symmetric coma brightness from the images, they found jets and tails of material. We've talked about those, right? Most emission features like nickel, iron, cyanide, and dicarbon align roughly opposite the sun, but tricarbon C3 emissions point in a different direction. That's what they saw. This tells us different molecules are being released from different active areas on the nucleus. So why does this matter? Let's put it all together. 3I Atlas has a so much larger nucleus than previous interstellar visitors. Its gas output changed in unexpected ways after passing the sun. Methane behaved in a way that absolutely breaks unusual expectations based on volatility. And then its chemical signature and jet structure don't match simple models. All of this means, at the very least, this object is unusual and fascinating. And we have all these anomalies, more than 20, that still have not been explained. And it has not been explained by the additional data that we have now gained. It's the opposite. So let's hope for more in the coming days and weeks. I have a playlist for Interstellar Object 3I Atlas. You should watch especially this symmetry of the jets that look, they just do like something artificial because they're just completely geometric 120 degrees angled away from each other. Absolutely strange. Check it out here in the end screen, but so much more is going on that you also should know about. So thanks for watching. Thanks for liking and hyping. Look down, look left, look right, look up, guys. There's so much going on. I see you in the next one, I guess. Hopefully, click here. Bye-bye.